Please join me in welcoming Dr. Max Nikias, President Emeritus and Professor Malcolm R. Curie Chair in Technology and Humanities at the University of Southern California.
Thank you. Hello, everyone. Greetings to all of you, and thank you so much for allowing me the opportunity to speak to you today in the beautiful country of Armenia. Today, I want to talk to you about one of my favorite subjects, the heart and soul of today's artificial intelligence technology revolution. Semiconductor chips, and more specifically the current upheavals roiling the global semiconductor industry. And I want to suggest some aspects of the booming semiconductor industry that you may not have thought about. Who would have thought, even 10 years ago, that semiconductor chips would become the world's most important industry? No other industry has the same mix of hard sciences and engineering, especially electrical engineering and applied physics, brutal capital intensity, and diabolically cruel complexity. The industry sometimes struggles to keep pace with the technologies it enables. It is an industry where disruption is the norm. Overall, the big picture shows a steady growth for semiconductor chips because, quite simply, we're finding more and more uses of these chips. And the chips keep getting better, which improves many technologies and creates new ones. Take, for example, automobiles. 10 years ago, a car might have had 10 or 20 chips, but the average car today has 1,400 to 1,500 semiconductor chips. Some cars, like the Ford Mustang Mach-E, have as many as 3,000 semiconductor chips. And the new EV cars manufactured by Audi and Volkswagen contain, each one of them, 8,000 chips. So in many ways, cars today can be seen as giant, powerful array of chips on wheels, communicating with each other and with the cloud. Nations are scrambling to grab a place in the complex semiconductor supply chain, or to tighten their grip on the place they already have. The manufacture of semiconductor chips is currently the world's most important industry. And no company of any consequence today could operate without the technology that semiconductor chips enable. The industry is very transilient. That means it is subject to abrupt, rapid changes or big breakthroughs. But it doesn't mean that the industry is chaotic. Rapid innovations sometimes make the industry appear chaotic. In reality, semiconductors have steadily advanced in step with Moore's law for half a century now. However, another major breakthrough has been in the works in recent years, but not only because billions of transistors can be packed together in a chip, but also stacking up many chips in 3D fashion. By doing so, faster computations, more memory, less power consumption can be achieved for more complex systems. It is one breakthrough after another. But why are the chips so important? How have semiconductors become the world's most critical industry? Semiconductor chips today are the foundation for the ongoing artificial intelligence revolution the 5G networks, robotics, telemedicine, remote work and education, virtual and augmented reality, and streaming entertainment. Even more advanced chips will be needed in the space race, going to Mars and colonizing the moon. Chips are a growing component of household appliances. They are the key ingredient of the Internet of Things. Advanced chips underlie many or most of the critical military applications. Chips are also critical for cybersecurity, digital advertising, gaming, distributed energy renewables, solar energy, biotech, and healthcare. So all these industries run on semiconductor chips. Again, chips are the brains behind everything. This past year, global sales of semiconductor chips totaled $612 billion. And the AI chips industry shipped a record of 1.2 trillion semiconductor units. Estimates are the AI applications will contribute close to $16 trillion to the global economy in just the next 6 years. AI could double global economic growth rates by 2035. NVIDIA's, for example, new Blackwell GPU has 208 billion transistors. It turns out that the chips NVIDIA made for video games were ideally suited to run AI applications. So it should be no surprise that NVIDIA today is the grand marshal leading today's AI parade. But the design, testing, verification, and manufacturing of the most advanced chips depends on a relatively small number of companies in Western democracies. Companies that are in the United States, the European Union countries, the UK, Japan, South Korea, Taiwan, Israel, and yes, Armenia. Advanced chips go through 1,000 or more exacting steps from initial design to fabrication. By the time a chip reaches a customer, its components may have crossed dozens of international borders. For example, the Dutch company ASML makes extremely ultraviolet lithography machines that etch the most advanced chips. A single machine can cost $150 million. The entire ASML machine has more than 100,000 components. It may be the most complex device ever made. And last February, this year, ASML showed off a $380 million machine, which is 165 tons weight, behind an AI shift. So the new ASML machine weighs as much as 2 Airbus 320s. So if we look at the semiconductor chips supply chain, from design all the way to the manufacturing of the actual chips and the many applications, this supply chain is very complex, and no single nation controls the supply chain from A all the way to Z. No one country controls that. It is truly an international collaboration, complex supply chain. And if we carefully look at the market share that each one of these nations control of the supply chain, especially of the most advanced chips, you can clearly see the blue is United States dominates with its companies in the design aspects of the advanced chips, but Taiwan and South Korea, with TSMC and Samsung respectively, dominate in the manufacturing of the most advanced chips. State-of-the-art chips today are less than 14 nanometers size of transistors, such as 7 nanometers, 5 nanometers, 3 nanometer chips, and with 2 nanometers in the planning design stages. For example, the brains of iPhone 15 Pro or Pro Max is a 3 nanometer chip designed by Apple and manufactured by TSMC. Apple says it is the fastest chip to ever power a smartphone. However, Samsung began making 3 nanometer chips this past June, and Samsung and TSMC are the only companies producing the sub-7 nanometer chips today. And TSMC hopes to begin a production of 1.4 nanometer chips by 2027. So as you realize, there are very few numbers left between 0 to 3. Notably absent from the exclusive club making the most advanced chips less than 7 nanometers massively is China. Despite spending tens of billions of dollars in recent years, China has been unable to achieve the competency to build the most advanced chips. So I just have a note here. I have to finish in 2 minutes. So while China still cannot produce the cutting-edge chips, it would be a mistake to count China out. The nation has rapidly mastered many other technologies, and there are signs they are beginning to make progress. Surprising many experts, SMIC in China recently began making 7 nanometer chip, and Huawei Mate 60 Pro smartphone, quietly released earlier this year, was built on an advanced 7 nanometer chip by SMIC. So the SMIC chip operates at a lower clock speed and does not perform as well as the TSMC chip. But China also manufactures massively many chips that are not state-of-the-art, but still widely used in many different applications. So to summarize, semiconductors have become the ground zero of the global technology competition. So, and I will try to wrap it up quickly, the semiconductor industry faces many challenges, but the single most important factor affecting semiconductors is the Cold War tensions that have developed in recent years between the United States and China. The geopolitics of semiconductors are rooted in the starkly different systems of governance of the world's 2 largest economies. To put it bluntly, it is democracy versus autocracy. And this global ideological struggle between China and the United States manifests itself primarily through economic and technological competition. Semiconductor chips lie at the very heart of that competition. So to summarize quickly, and I'm going to skip everything else, since they want me to finish. When we look at the industry today, the biggest threat that the industry faces is not so much China. It is the shortage of talent. And This is the single biggest risk the industry is facing. And there is a great need to educate talent in this industry in order to meet the anticipated demands and the creation of the new jobs that this industry is going to generate. So what we are moving gradually is for the most advanced chips and decoupling and going into two different solar systems, as I would call them, or with two different supply chains, one that pretty much is China, and then the other one is the United States, with all the Western democracies that I pointed out earlier. Thank you.